Okay, so this video is going to help explain what to do for assignment 2 in Unit 4, Activity 2. So the first question, it gives you a graph and you have to write a function or the equation of a function in factored form that could represent the graph. So the first thing we're going to do is I'm going to add some positive and negatives along the bottom. And the reason why I'm going to do that is so that you understand where they're coming from. So if I look before x equals -2, so if I highlight that value right there, before x equals -2, I'm going to have negatives. And the reason why we have negatives is because the graph is below the x-axis. Then when we look between -2 and +2, we are inside and have a positive until we get to -1. Whoops, I wrote that over a little bit too far right here. So I'm going to erase that. So we have positive until we get to -1. Then from -1 to +2, we're in negative again, and then we're still negative over here. Now, to write the equation, we want to identify our zeros. So I see I have a 0 here, 0 there, and then I have a 0 here. The fact that we have a maximum, a minimum, and then another maximum means that it has to be a quartic function. So I have y equals a, and then I'm going to have x plus 2. I'm going to have x plus 1, because -2 and -1 are zeros. And then I'm going to have x minus 2, and I'm going to square that because it's a double root. It doesn't actually pass through the axes, so I have a squared value right here. Now I need to figure out what a is. So in order to find a, pick a point on the graph. And in this case, the easiest point to pick will be the y-intercept because it's at 0, -8. So I'm going to sub that in. I have -8 is going to equal a. Then we're going to have 2 multiplied by 1 multiplied by -2 squared. So we will have -8 equals 8a, which means -1 equals a. So in this case, it worked out very, very nicely. So we'll have y equals -1. You can either include the 1 or not. X plus 2, x plus 1, x minus 2 all squared. So that would be a good model for this particular graph right here. When you're justifying your answer, as long as you're explaining that the zeros are used to generate the base function, and then in order to find a, you're substituting in a value. The other thing that you could use to help you here to recognize that a has to be negative is the end behaviors of a quartic function. Since they're both negative infinity, that means that there has to be a negative value out in front. So hopefully that helps with number 1. In number 2, you're given a picture that's been hand drawn, and you're being asked to sort of explain what's happening in each step. So I kind of mimic that here. So this equation up top, so this is the function. Okay, so that's the function. And again, we have the negative over here because it's below the axis. We have the positive because it's above, negative below, and negative once again. If we look at the equation, x minus 8 is squared. That's a double root because it doesn't actually pass through. Then we have x minus 2, x plus 2. This 9 over 56 out in front, that's the value of a. What's happening in this step right here, when you're explaining to somebody, you're identifying the y-intercept. What's happening for the second step, you're trying to identify if it's above or below the axes. So because this here is negative, that means the function is below, and you actually have a coordinate at -4, -60.75. So that could help you with the graph. Same thing over here. If we go and look at the interval between 2 and 8, so if you substitute a value in that interval, you'll notice that you end up with a coordinate at 4 and -6.75. Now this graph is not to scale at all. These little steps over here would be in order to get it to be much more accurate. And then likewise, when we substitute 9 in, it's to see if we're above or below the axes. You'll notice there's one interval not subbed in here. We could have subbed in between -2 and 2, but we didn't need to do that because when we're finding the y-intercept, that also told us that that interval between -2 and 2, so between -2 and 2, we get a positive value, so it's above. Okay, so that's what it's asking you to do in question number 2. It sort of wants you to explain those steps that are on the graph in the top corner, how you generate the positive and negative signs, how you determine if you're above and below the axes, how you state what the values of the zeros are. Finally, in this question, in number 3, you're given a couple of different functions and you're asked to sketch what they are and then compare their shapes and key features. Okay, so when I do that, this first question right here, before I start graphing, I notice that it can still be factored. So then I'm going to rewrite that. So I'm going to have negative. You'll notice x plus 2 is there 2 times. So I'm going to put a square on it, and I have x minus 3. All right, so when I start graphing that, I know that I have a point at 2. I know that I have a point at positive 3. And I want to figure out where the x-intercept is. So I'm going to substitute in 0. We're going to have a value at 6. So there's a y-intercept at 6. The other thing that's important is that we have a double root at -2. Now, this here is going to be a cubic function. Okay, so I want to know before -2 if we are above or below the graph. So if we were to quickly substitute -2 into, or sorry, -3 into the expression, we would find that our function is positive. Or if you know that because it's a cubic function and the leading coefficient that we have out here is negative, it has the start above. So this is a sketch, so it doesn't really matter. -2 is a double root because we're squared. Then it's going to go up. We have our y-intercept, and it's going to come back down somehow because it's cubic, and then look like this. Okay, so that's the first graph. Having a quick look at the other function, it's going to be very similar. Okay, so for the other function, I once again have a 0 at 2, and then we have a 0 at 3. So they have the same values in terms of their intercepts. But when I determine where the y-intercept is going to be, I just actually realized I made a mistake right here for that y-intercept because this is squared. So that's 4. So the y-intercept should actually be at 12. I'm just going to quickly erase this and start over because I want the graph to be as accurate as possible. Okay, so my intercept is at 2. We're at 3. That's right, 2 squared is 4. So it's going to be at 12. Okay, and then the same reasoning. It's possible that this could happen. So I'm just going to sketch this. And that's good enough for what we have right now. All right, now the other graph. Also negative, also has a 0 at -2, also has a 0 at this value. So the same kind of graph is going to be happening. It's going to have the same almost general shape. The y-intercept here is going to be, so this one is going to be at -18. So it's all the way down here. So then when I graph, it's going to pass all the way through here. Perhaps, oops, that was bad. Let me undo that. So it's going to pass through here, come down, pass through this, and then this is our double root. So I have my arrows. So when you're comparing these two graphs, they have the same shape. So the exact same shape when we're looking at it. Same rate of increase, however, the main difference being their y-intercepts are different. So that's for these particular graphs. If your leading coefficient is different, or you don't have a double root, or a variety of things like that, the steeper the lines are for your graph, the faster it's going to be growing. So this is a sketch in terms of using the zeros, the y-intercept, the fact that we have a negative, meaning the end behaviors are going to be going to negative as x goes to negative infinity, y is positive infinity, and then as x goes to positive infinity, y goes to negative infinity for both of these curves. So hopefully this helps with those questions.